Hey guys, this is Mr. Sal. We got this question from a student about elimination, and it is set up a little bit differently. We're kind of used to seeing these already in standard notation or standard form of a linear equation like we do see in this one here at the top. So let's go ahead and get started. Now, like I said, that top equation actually is already in standard notation, so it's the bottom one that we're really worried about. So I'm going to keep the top one as is, but I'm going to manipulate the bottom one, right? I'm going to solve it for essentially what would be -4. So that goes back to 1.9 where we were solving literal equations, or just manipulating them, all right? Here's what I mean is I don't want that plus 3y with the -4. I would rather have it on the same side as the 2x. So I am going to zero it out. Okay, so I'll subtract 3y from both sides. Is going to make this a new equation. -2x minus 3y, now it equals -4. So this is how you line up the variables essentially in columns like this, right? Because now it's -2x minus 3y equals -4. Now the idea here is to use elimination to solve this, which is good because right now it's set up to solve it pretty quickly. Specifically, and this should take some analysis on our part before you start working with this at all or changing any of the coefficients. You should look at the coefficients as they are right now. And if I look at the coefficients of x, we got 5 and -2. That doesn't really help us right now. What we would like to see is something like this where the coefficients are opposites. So the y has in black there has a coefficient of +3. The red y has a coefficient of -3. So if I go ahead and go straight into just adding these together, it will give me a new equation where the y's are going to eliminate. Let me show you. 5x minus 2y is 3x's. Now over here we got 3y minus 3y, which does zero that out, okay? So I got 3x. Now it equals -6 plus -4, which is -10. And to finish solving this, we just want the coefficient of x to be 1, so divide both sides by 3, and x equals -10/3. But again, I'm just pointing this out, the idea of lining up the x's and y's, which is why I didn't put the -3y to the left of the -2x term, because up here in black, the 3y was to the right of it, okay? X, y's equals numbers. That's how we want to set up. That's standard notation, ax plus by equals c. So now that I figured out an x value, I can go back to either one of the equations. I'm just going to use, since I solved for x, I'm going to use the top one. Not that it matters. You could have used the -2x equals -4 plus 3y. But I'm going to check with this one. So I'm going to replace that x with, and I'll try to use the same color, -10/3 there. And just solving this, right, so we got 5 times -10/3, that's -50/3. I am keeping these in fractions on purpose. And from here we'll zero out that -50/3. So add 50/3 to both sides. And again, that's to zero that out, so we'll drop the 3y there, which now equals, for me I get 32/3 here, and then the final thing we're going to do to solve this, again, I don't want a coefficient of 3. I'd rather it be a 1, so just divide both sides by 3. And all these calculations I'm just using my calculator for. So I got 32/3, I'll divide that by 3, and it just comes out to 32/9. Okay, so I used both equations to get the x right here, and then I used the top equation to get the y down here. But the last thing I do want to do is just check the bottom one to make sure it gives us a true statement, which is -2x equals -4 plus 3y. And I'm going to do all the work here once. So there you have it. I put the left side in my calculator. I got 20/3. I put -4 plus 3 times 32/9 in my calculator. I got 20/3 as well, which means that's a true statement right there. So since it's true, now I know that both of my answers here that I had, x is -10/3 and y is 32/9 is the correct answer on this one. So that's how you set that up and solve it using elimination. Thanks for watching, guys.